Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer and aspiring software architect.
And I'm Beej, the journeyman developer sharing my journey in development.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
Be our test, because our code is a mess. Testing code is not easy. You have to think about all of the different ways that your code could go wrong and then write tests to cover it. You generally write more test code than functional code when creating unit tests, and this takes time and slows down initial development. With all that, unit tests reduce the overall time and cost of developing and maintaining software by finding bugs and issues earlier in the process. There are several objections, though, that you may hear from fellow developers and managers when trying to introduce or promote unit testing at work. And we're going to discuss some of the more common objections that developers face when encouraging unit testing and sort of how to overcome them. But before we get started, Will, what have you been fighting this week?
I am in audit trail purgatory.
Oof.
And it's purgatory instead of that other place because you do eventually get out. But we've got a new system that we're kind of building, and I got the main database structure and stuff in place, and then was like, hey, let the developers kind of beat on this thing for a little while and find all the places I screwed up before we put audit trails in, because you gotta. If you don't do that, then you're having to go back and fix stuff. It's kind of like writing unit tests that aren't quite right. You fix the code and then you got to go fix all the tests. So you just wait a minute. And so that's kind of what I'm doing. And so it's a pretty complex system. So like we have a hierarchy of entities, like business entities in it. And then we have settings, which are in their own hierarchy of arbitrary depth, and features, which are in their own arbitrary depth of hierarchy. And then there's permissions that are the join between features, users, groups, and
ooh, man. That just
and
sounds
how
nasty.
that all works out, like how you figure out what permissions somebody has. Well, I've got all that. Now that was like several days. I went through a whole bunch of whiteboard markers, destroyed my household supply of whiteboard markers to get that done. But now I'm going back and I'm having to backfill the audit trailing for this stuff. And what does that look like? And how do we make that performant? So that's where I am. And yes, that is all I'm doing right now. How about you?
Well, I have been fighting caching issues.
I won't trade with you. I like my issue better. I take it all back.
I'm not sure if it's in Hibernate or .NET itself that is caching the expressions I'm creating. So originally, my idea was I would create the expression dynamically with just the criteria passed in because it's for a search.
Right. So you're doing LinkedIn Hibernate?
Yeah.
Or whatever they're calling it this month.
However, it was caching the expression and not creating a new one when called within the same session. So if I search by one parameter but not another, it would return the right results from the view in the database. But then if I searched by that other parameter, it wouldn't have created it would use the initial expression.
The previous one, yeah. So it's like it's getting the same cache key for two things that are not the same.
Right. I haven't yet figured out what is causing the caching to work that way. So what I had to do was change the expression
to include all the possible.
Right.
Yeah, and that's so much fun, right? Mm-hmm. I do think that if I remember correctly, in Hibernate does some of its caching. It looks at the entity, the in Hibernate entity that's being defined, and so you're doing multiple queries on the same entity, and you're building up an expression tree. Is it possible that you're taking that expression tree and pulling it before it's done, and it's getting cached then? Maybe
I'm not sure. So the way I figured out what was happening is I had to look at the SQL that it was sending to the database. It's funny we're talking about unit testing because that's how I got to the SQL that was being passed to the database. But that was where I saw, so the original expression is like, all right, for each of these, it's like true equals true, true equals true, and then it gets to the parameter that I wanted to actually search by, and it has that SQL in there to search by that parameter. But then the next one, the SQL was the exact same, except for the variable being passed into that parameter was null because I was passing in a different criteria.
Right.
But it was basically the same SQL statement.
Right. And so you would have in SQL, and it's SQL Server now, this is not Oracle. I would assume Oracle does something similar. The execution plan for that query will also get cached.
Yeah. So it wasn't on the database. This is before it sent it to the database. So this is in my
I'm just wondering if they're
code.
emulating something like that.
I don't know. It was because, like I said, I saw the SQL that it was creating, and that's where I realized, the expression is being cached because the expression is where it's creating that expression tree.
It only put the stuff in if it actually needed it versus it's got all the things in there and the expression itself determines whether they're active.
Exactly.
Yeah.
That was what I was doing. And it was supposed to create a new expression every time it got hit. But if it was within the same session, the interesting thing is I didn't catch this in any of my unit testing because I tested one at a time. It was only when it got put into dev that I started recognizing, hey, this isn't getting back the right results. And so I had to write a unit test that called multiple times to be able to figure this out.
It was weird.
It took me 2 or 3 days to really just figure this out.
We've had similar problems in SQL with parameter sniffing, where you pass parameters in, and the first time you call it makes a SQL execution plan. In other words, it's coming up with a SQL. The next time you call it with the same, with a different parameter, it tries to use that previous way of doing things, and it's not optimal for the data set that's coming in, like if you have optional parameters. And so it seems like a similar thing moved up a level.
That's pretty much exactly what's happening. Yeah. So
I'm so glad that is not my problem.
So so the way that I temporarily have fixed it is I changed the expression that it was creating to include everything in it. And then if it caches it, it doesn't matter. It just passes the parameters in. Yeah. Not the most optimal way of doing it.
We had to do something kind of similar on ours. And the other thing we figured out with SQL was when the parameter comes in, if you immediately assign it to another variable and then use that variable in the actual expression, it cache busts it because it's not smart enough to figure it out. So that's what we've been doing.
Oh, that's interesting.
But I don't think that would help you. But
yeah. So some of the stuff that I looked up was turn off lazy loading to not do the second level caching. And I'm like, yeah, I've got that turned off. Now, on a happier note, it's just a few weeks until Christmas. I've gotten most of my shopping finished, just a few things left. And I'll probably get those from McKay's, which is a kind of a used everything store.
Yeah, mostly books, CDs, cassette
CDs,
tapes.
Yeah.
You still got cassettes,
games, all sorts of stuff.
You go to stores now, and a lot of times they don't even have CDs, much less cassettes.
They got records there too. I got a couple of records last time I was there, but I love that place. It's awesome. I'm gonna miss it. I've been living really close, 5 minutes away from it, and so now I'm gonna be about an hour away.
You got to take $150 and just buy the store. Probably just leave with a pickup truck full of stuff.
I could. But speaking of Christmas, I've got something Christmas related for IoTs. So last week we talked about the new Raspberry Pi that came out. This week I've got a project to use a Raspberry Pi and the Blink dongle to create Christmas lights that light up whenever someone tweets #Christmas or your #holiday of choice. This triggers a change in the lights to let you know whenever anyone is talking about your favorite holiday, and it uses the Neo service on the Raspberry Pi. The blocks that it uses from that service are Twitter, Counter, and Blink 1. Now, the Twitter block polls Twitter to get all the tweets with your hashtag of choice. The Counter block keeps a count of all the signals passed through it. And then the Blink 1 block changes the color of the RGB lights based on the counter block. It's a really neat project that you can do yourself or with your kids for your hashtag holiday of choice.
Yeah, and I could see you could modify that for like Nashville weather and just put like a speaker on it and, like look for like hashtag snow.
That's not
and then have it like start just blaring, buy bread and eggs. Clear the store shelves now.
That's
I think
one way
actually everybody already has one of those apparently.
So I'll have a link to that project in the show notes. Who's talking to us this week?
We got a tweet from Jamie Epstein, and we actually met him at Developer Launchpad this last weekend. Was that last weekend? Yeah. So D8/105, that's it's day 8 of 100 Days of Code. Went to my first meetup. It was a code jam at NSS run by BJ and Will of @CompleteDevPod. Learned what a code kata is and finished my CSS pre-work. #100 Days of Code.
Yeah. Jamie, it was really great meeting you. Enjoyed talking and getting to know you. We look forward to seeing you at our next meetup. Thanks for the shout out on Twitter. Send us a DM with your contact information because we've got a Complete Developer water bottle just for you. Guys, if you'd like your very own Complete Developer water bottle, leave us a review on iTunes or comment on the website or any of our social media. We post all of our episodes to Facebook, Twitter, LinkedIn, and Google+. We're also on Instagram and Tumblr. You can check us out each week on Facebook and Twitter Live, where we talk about what's going on in the tech world and answer listener questions. Or join the conversation anytime via Slack by going to slack.completedevelopernetwork.com.
Automatic and unit testing have become standard in modern software development. It reduces the overall amount of bugs found by QA, UAT, and even in production. Tests also change the way code is written. Developers have to build their code in functional units separate from other units of code. They have to avoid overly dependent, tightly coupled code. It's well known that it is easier to write new code than it is to read it. So adding code to an existing code base creates the potential for new and more bugs. As you add code, the bugs become more elusive and harder to find.
You're not likely to find anyone that doesn't think code should be tested before going into production. However, not everyone likes writing unit tests, even though they are useful in preventing bugs from reaching production. They will likely have objections explaining why they don't want to write the tests. Some will say the tests aren't part of development or that code is tested by QA after developers are finished. There's a lot of different reasons. We're going to talk about several objections that you'll face when writing unit tests. We've each heard all of these in various places that we've worked or consulted. For each one, we're going to kind of discuss the objection, a little bit about where it comes from, and some potential ways to overcome it.
So the first one is the most obvious, and that is that writing unit tests slows down development and costs too much. This is the most frequent one that I hear. The number of conditions to test increases with the complexity of the code you write. So as you add code, you have to keep on adding tests to cover changes to the code base, because the original tests typically are not going to cover the new code, because how did they get written otherwise?
Yeah. If the new code interacts with existing code, it can introduce errors to previously tested code. So you may have to rerun
all the tests. You got to test all of them. Testing also changes how the code is written in the first place. Code that's not written with testing in mind is difficult to write tests for. Like, there's whole books on how to do this, and basically those books can be summed up as, this really, really sucks. You don't want to do it, but here's how you can do it if you have to. Right?
Yeah.
Like, it's like a survival book.
Yes.
Here's how to survive on top of a mountain wearing only your underwear. Yes, that's something you can do. However, maybe not optimal. Bigfoot might find you attractive. Who knows? It could end badly.
Well, not if he finds you attractive. But yeah, it's and I have some of those books. I know I can see.
I thought you were about to say I've been stuck on a mountain with Bigfoot. What do you say? Like, well, you were in East Tennessee for a while. Dang.
I have some of those books. I can see some of those books here in.
Yeah, it's over there in the survival book section, actually.
Yeah.
Because it's the same thing.
Pretty much. Most likely, you're going to have to refactor the code to create testable units.
Yes. And
if possible.
yeah. And of course, you got to use the word refactor like 800 times in a meeting with marketing people because they like that. If it's not possible, your test will likely be overly complex to account for the code. Like, for instance, if your UI is tightly coupled to your database, testing that is all kinds of fun.
Oh, man.
I've done that, by the way. Don't ever do that. Like, that's, again, mountaintop, Sasquatch, bad stories.
The prime example that I can think of is dependency injection, because I've had to deal with this not too long ago. So I wrote sort of an internal service for us to use. And I think I wrote it, and I wrote one update to it. And then one of my coworkers had to come in and add a search functionality to it. Well, I had built it with testing in mind, injecting dependencies and all that. And when she came in, she was in a hurry and didn't use the inheritance I'd created, didn't use the dependency injection, just spun up a whole new repository in, the controller that already had a repository that she could have just inherited from. But, that's life. So when I came back to add some stuff to it, I saw this and I'm like, I can't test what I have to add to it.
Yeah, you got to rip her stuff back out or fix it before you can even start.
Exactly. The thing about this is testing reduces the overall development time because it finds faults early.
Maintenance is the most expensive part of a software lifecycle for most projects because they live longer than they were actually being built. So, people are constantly touching it. Unit tests are a major part of making your code maintainable. Without them, the maintenance team will not know if they added something that broke existing functionality. It's really nice to have a set of tests that you can run and you can go, okay, I didn't bust anything, or I didn't bust anything that these people know I busted.
Yeah.
Is really what you're actually saying. Like, you can't actually assert that there is no bug. You can assert that there's a bug. You can't assert that there are no bugs. So,
you can't prove a negative.
Right. So it's just as good.
Yeah. Yeah. Also, when adding changes to existing code, if the original code was covered, those tests will identify breaking changes.
Yeah. In the short term, it does increase the amount of time in development because doing stuff right tends to do that.
Mm-hmm. However, it does reduce QA and UAT time if you have both of those, or even just one of those.
Yeah.
Because well-written unit tests find most bugs early before they make it there. And it's so funny because I went through one sprint where I tasked out writing unit tests, and QA said, I found less bugs when you wrote unit tests. You should do that more often. I'm like, I do that all the time. Yeah. You didn't actually find less bugs. You just perceived that you found less bugs.
Yeah. So it's a Heisenberg.
Yeah.
You open the box and the code fails.
Well, it was the perception of they saw that I wrote unit tests. They saw the task for it. Whereas before I'd been writing unit tests. And after I stopped doing that, I was still writing unit tests. I just wasn't listing it as a task.
Right.
And I was like, yeah, you found the same amount of bugs. Most of the time when QA finds bugs, it's more integration.
Yeah, it's like UI stuff, which is hard to test.
Right.
Or it's, calls across the network. Mm-hmm. It's big components interacting. You find out that, oh, hey, they didn't deploy this other service that they said they would. Because I swear every DevOps team does that to you at some point, if you have one. Otherwise, you do it yourself. Development is a lot more than just writing code. Like, saying that development is writing code is basically saying it's typing. That's just not what happens. It also reduces the number of errors found by users because you're going to make the code more stable. You're going to make it more easy to troubleshoot because you've got to build things so that your tests actually tell you stuff when problems come up. So it really fixes a lot of issues.
So while it does initially slow development down, in the long run, it speeds the whole life cycle up. The next objection that you hear is writing unit tests is just too difficult.
Yeah, and this usually means that you've got a crap code base that needs to be refactored. Because, like a lot of older code bases, they weren't written with this in mind. Mm-hmm. And so you're like, oh yeah, I want to add unit tests. You're not going to. It's tightly bound, way deep.
And some of the older frameworks are not built for unit testing.
Yeah, like ASP.NET.
Yeah.
Before core, especially when you start looking at things like web forms, which I deal with all day.
Yeah.
You're not unit testing that unless you want to fake HTTP context and spend like 4 days writing a mock for that thing.
Yeah.
And even then, you're not going to mock it well because it's kind of weird.
And you're going to, like you said, spend time creating mocks or have to split the code into smaller testable chunks, do some serious refactoring.
Yeah, because like in web forms, it loads up the form and that thing is tightly tied to the HTTP context, the session, the cache, to IIS. It's like it's snarled together. And what people did is they said, oh, hey, I've got an event on this thing. I'll do my business logic right in here too.
Right.
So I don't have a bunch of files. So you're going to have to pull that crap out and test it, which is going to be very interesting at times.
No. Some areas of code are just difficult to test. I mean, we talked about the frameworks that cause that problem, but then just in code in general, code involved in I/O or that relies on a lot of side effects.
Yeah, including timing.
Yes, can be hard to predict. You can mock a lot of things, but at some point you have to test the connections to things like the database.
Yeah, and you want to be able to test the connection, but then not break if the data changes too, which is also a fun one, right? Like somebody, we had some tests in our code base that referred to IDs in the database.
Yeah.
Well, guess what? Those tests worked for the duration of time that the person was there maintaining them. I don't even know who wrote them. And I've been there 3 years.
Yeah, I've seen tests like that.
They don't work now. Yeah, and that's a very bad spot to be in because you got to try to find examples that meet the testing criteria in your current database, and you might not entirely know what that is, and it may be that those tests have been broken for years, or you could just highlight them and hit the delete button like I did.
So one thing that I ran into recently was, while the DBA was building a view for me, I was writing the code. And so I wrote unit tests with mock data because the view wasn't there. And it wasn't until we pushed it to development, the dev environment, that we realized, hey, things aren't populating in the view the way they're supposed to. Because I hadn't tested the connection to the database because the database didn't exist at that time.
Yeah, there's a certain degree to which unit tests are kind of useless without integration testing. And that's...
You really need both, and that's kind of what we're getting at here. Also, making your code testable adds complexity to it.
Yeah, it's a lot harder to write it. You're going to have dependency injection.
Yeah. You're
going to have not static methods laying everywhere. Like that makes a lot of stuff harder. You're going to have to do something about caching too.
Yeah.
Just a lot of things that you're potentially relying on at a low level, you've got to move those out and still keep it performant.
It also requires thinking about what can go wrong rather than how to make something work. So it's a different mindset writing tests.
Yeah, it's like the difference between a entrepreneurial business owner and their lawyer as far as the way you think.
The thing with that is, though, the more unit tests and testable code you write, the easier creating that becomes.
Yeah, because it becomes second nature for one thing, but the structure is already there. So like when you're looking at something and you're copying existing structure, to whatever degree you do that, hopefully not Control-C, Control-V, but like going, how did I do this before? Let me keep that up and go, okay, I'm going to do something kind of similar here. Or if it's already there.
Yeah, or if you're looking into, if you're updating something existing, you're looking at, all right, what's the structure there? Let me use the already built-in structure and not just force my own stuff in there because
I don't want to get blamed when it breaks, and if it looks like the other guy's code, he'll think he did it.
Yeah.
No, not really. I mean, but like, you don't want to be in a situation where it's like, okay, I'm going to put tests in, and I've got to spin up dependency injection in this stupid thing, and I've got to, fix the way .NET routes, and I've got to do this other, all this other stuff for this one method. Whereas if it's already there, writing the second method is way easier. In fact, it's easier to do it right than it is to do it wrong.
Writing the 100th method, it's just natural. It's just, it becomes the way you do things. Like for me, going back to the dependency injection, I spun up a really quick service to handle something that we needed that I didn't expect to last very long. Just, we need it right now to do something. I was so used to doing dependency injection, I threw it into that.
Yeah.
And I'm really glad I did because it's lasted a whole lot longer than I expected.
Yeah, I got some code like that I'm like, I can't believe that's still running. Why hasn't somebody put that thing out of its misery?
Yeah.
Now, another objection that comes is that tests halt new development, which is true, but we're going to touch on that in a minute. The tests may not pass after changes in business logic. Of course, the thing is you should be writing the tests with it. Like this is treating testing like it's a second-class citizen, which is part of your problem.
Yeah. Changes in business requirements may affect the underlying code. And when the code is modified or the outputs change, the test may not pass because they're testing the wrong logic.
Yeah, I mean, it's like a fireworks factory owner going, explosive safety is kind of secondary to our mission of making fireworks. Like, something's going to end bad there.
I notice you use that voice a lot when
I do.
You're talking
I'm thinking of someone in particular.
Improperly written unit tests cause the code to be too rigid. Internal services and APIs that your code is calling may change based on issues that come up or new business requirements. If external code changes break previously passing tests, then your test code is too rigid.
Yeah, and I've seen quite a bit of that where, they're calling some external service and they're expecting an error message. That's the favorite one, right? It returns an error message, and instead of going, hey, what's the type of this thing? And, does it throw an exception of this type? They go, let me look at the actual text.
Oh, man.
And somebody runs it, they run the unit tests, but they've switched their desktop environment from English to French. It's the same type of exception, but the error message says something else. Oh, now all these tests are failing because you made it attached to something that it really isn't attached to.
Or the most annoying thing I've found with unit testing, in part, it's because I've been working on this project for a while and I've grown and learned things, and the way I did things a year ago is not the way I do them now. But when, say, your data standards change and you're no longer treating phone numbers as int64s, but are treating them as strings.
Yeah, okay.
And so you have to go into all of your tests and change every single phone number to a string.
Yeah.
164.
Ah.
That's how many I had to change.
Yikes.
Took me about an hour.
Yeah, that's a wee bit annoying.
That was.
Well, and the other thing too is like your testing, like you still have to follow software best practices with your tests, like not repeating code, which I find I burn myself with that a lot because I'm really good at fixing that and getting rid of duplication. And so like I'll have like tests with like generic constraints. And I'm looking at it going, how did it come to this? Like I can't even tell what this base class is doing now.
Yeah.
Yeah, it's not good. But.
So the thing about this is unit tests are living documents and they need to change with your code.
Yeah, they can also be refactored and changed based on the needs of the business. Like your business may find that, hey, we've moved into this other vertical and this other thing happens that is completely different. And you've got to add tests for that, or you got to alter the tests. Like that's normal.
Yeah, when you change the underlying code, you need to be in there changing the tests as well.
Yeah, and I'll tell you something else that's a weird anti-pattern is when you change the underlying code and the tests don't break. And
we'll talk about that in a little bit because if it's the output, if you change because what you should be able to do is change the method. Change the internals of the method and the output doesn't change, your test shouldn't fail.
Right.
And if built properly, you should only need to change the tests covering the units of code related to those business changes.
So the next one is another one that I really love to hear, and that's that we're too busy to write unit tests now because we can write them later. That's sort of like I'm too busy to exercise now. I can do it later, when I'm 80.
This typically comes from management, and it indicates that your deadlines are not very realistic.
Yeah, and it usually requires you to sacrifice code quality for quantity over time, which eventually burns you because eventually you can't get the quantity either. Mm-hmm. Managers with this attitude do more harm than good. Of course, they also move up quickly.
Move up or move out.
Yeah. Later never comes. It's like the same thing of, getting your life in order, getting your finances in order, actually testing your code.
I heard my dad say as a preacher, and I've heard a lot of other preachers say too, is you hear a lot of people say, oh, I'll start going to church once I get my life back together. And once I get things back on the right path, then I will take the time to go to church
and
and
it is
stuff.
very much like unit testing, actually, because you should be, this is part of fixing it.
Yeah. And the thing is, and the point that they made was that going to church was part of getting your life back together.
Yeah, it's like I'll start exercising when I lose weight.
And I will say from personal experience, when I found out I was allergic to onions and the IBS and everything, I lost about 20-25 pounds there.
It was a rough 2 days, wasn't
it? Yeah, from being sick for 2 or 3 months. And that galvanized me to go, hey, I've lost quite a bit of weight. If I exercise some, I can lose some more.
Yeah.
So I get where that altered thinking comes from.
Yeah, but it just doesn't apply, and it implies a lack of understanding of the causality.
Right. Because in these situations, developers are never going to have time to write unit tests.
No, because you're writing more crap code that's going to break and start fires.
Yeah. There's not likely to be any break between projects. The next one's going to be waiting on the team as soon as they're finished.
Yeah, and they're going to jump off of that one back to this one when stuff breaks, too.
Exactly. And it's going to put the next one behind.
Yep.
And it's a snowball pattern that leads to burnout and company failure.
Well, yeah, and it also leads to half the team leaving.
Yeah.
And the new ones come in and they don't understand what's going on, so they sure as heck aren't going to start writing unit tests to fix that because they're already behind. Mm-hmm. Yeah, it's just a bad, systemic problem.
The thing is, it's hard to fix because you really have to change the structure of the company.
Yeah, and this means that you've got to convince management of the costs of their behavior, which is kind of hard to do in the way that most developers position themselves.
Mm-hmm. So if the company's been around for a while, you may have the idea that you can go and say, hey, you can show them where they've never had time to write tests, quote unquote, later.
Yeah, which is entirely true. It's also not going to work.
Right.
Like you're not, as a developer, typically in a position where you are positioned well to say that and have people listen. What you can do, though, is if you've got a junior dev or you are a junior dev, you can write unit tests as an exploratory function.
This is a great place for new junior developers to learn the code base.
Yeah.
That's what I did when I started my first development job outside of working with you, is I came in and they just put me on writing unit tests. Within a week, I was committing code because I had learned that code base inside and out from writing tests. Because you have to learn what the functions do, why they do them, what goes in, what comes out. You really get to know that code base.
Yeah, our junior dev started out doing testing.
Yeah.
And I mean, he knows his way around that code base. Like, he can fix stuff I can't. Mm-hmm. Because he tested first. Now, it wasn't writing unit tests, but it was just that exposure. So if you mix that in with the actual coding stuff, yeah, that's a win. However, if you do want to go and say, hey, he never had time to write tests later, it's never going to happen, be prepared. Because the other option comes up too, right? Like, you may just want to leave.
Yeah. And this might be something in your exit interview that you say, hey, one of the reasons I'm leaving is we don't do this. And you say,
and I can see it coming.
Yeah. And that is very valid. That is very good criticism. Yeah. And coming from someone who is leaving versus someone who is still there may mean a lot more.
Yeah, especially, depending on timing and everything else. Mm-hmm. Another thing that you'll hear is that this piece of code is so trivial that it doesn't need to be tested. Mm-hmm. And, that's a weird one because it's like, if it's that trivial, then you can write a test quickly, can't you? Like, quicker than we can have this argument.
Yeah. These cases are like small classes with little involvement in the overall application. They may have only a few methods that are rarely used. The class itself may not be used often enough in the code, and its functionality could be trivial to the actual business need.
Yeah, but the thing here is that no test or no class is too trivial. to test. In fact, really trivial classes are a great way to test your unit testing framework. That's a place you should start.
That's a really good idea. Yeah.
Because, hey, it's not going to break anything. That's great. When you're cramming new stuff in the code base, that's where you do that.
Mm-hmm. While it may not be necessary for the business needs, other classes may rely on this trivial class. And also, as changes are made in the code, that class may become more necessary.
Yeah, because people find it. That's, that's what IntelliSense does. I've got some stuff with extension methods that I put in like a year or two ago, and it's used in numerous places in the code base now, and I didn't do it. Somebody found it and said, "Oh, this is great." And it's not really that great. It's kind of poorly written, but it worked. At the time, I wish I had tests around that, because guess what? Other people can use your code. That's sort of the point of reusable code.
What's always fun is when you click on the references to the class and you go, "Hey, where did that come from?" And you realize that, you wrote it.
Oh, yeah. I always find that on like the initials on commits.
Yeah.
When something really boneheaded happened and you're like, oh, yeah.
Yeah, exactly. Also, the class is likely to grow over time as functionality is added to it. So you don't know what's going to come of this class. And so you need to go ahead and have an initial set of tests there that can be built upon.
Yeah. And I would say that, only methods without business logic can possibly be skipped in testing. And I put, possibly in there because, a lot of stuff ends up being business logic that you don't think is.
The thing is, these are your getter and setter methods. These are like your
DTOs.
Yeah.
Yeah. Of course, the thing about that is, I've seen this happen where somebody goes, "Oh, I don't need to test this data transfer object." But then somebody goes, "Hey, wouldn't it be great if this thing had a constructor that took the other underlying type and put stuff in there? Now it's got to be tested." And there's not a structure for that. And they go, "Oh, it's so minor." And they just kind of blow on by.
Well, see, this would be a case of when you add that logic, you have to add the tests.
Yes, it would. But it's almost like I've seen that creep, I guess is what I'm saying. I would say in general, I agree with you, though.
So the next objection that you'll hear is only integration tests really test the code.
Sure.
This assumes that the only way to test code is with real world tests.
The only way to test the engine's on the highway.
Yeah, exactly.
But, when there's black smoke billowing out of it, you'd like to find where that is. Mm-hmm. Instead of having a fireball going 80 miles an hour through Metro Nashville.
That would be quite interesting.
Yeah, because they're speeding. And they're going to hit those potholes on 440, and there's going to be like a disaster. Yeah, this is really screwy because it assumes that the only way to test code is with real-world cases.
The idea here is that in order to completely test a feature, black box testing of various situations.
Yeah, okay, so here's the thing. Integration tests are holistic. Unit tests are diagnostic. That's what we're actually going for. Each integration test would test all the functionality of a path in the app. Now, if your app is of any sufficient size, you're not going to have integration test coverage of all the things. That's not happening. But you could have unit test coverage of all the things that points out where, hey, maybe, the integration test didn't bust, but this unit test busted. There's a path I need to add.
Right.
That helps you kind of triage that. This tests both the method logic and the functionality of the infrastructure.
Unit testing creates a lot more test cases than a single integration test. This may be part of the objection, or integration tests have to be created for every time a component is used.
And all the weird ways that it gets used.
Right. However, these unit tests only need to be created once for each unit of code. So it doesn't matter how that unit of code is being used. You only need that one set of unit tests for it. You don't need a set of unit tests for every different way that it's being used. So, for example, you're testing a call to the database. You don't care if it's a search function, if it's a get function, whatever. The test is the call to the database.
Right.
They test the components regardless of where and how often they're used in the application.
Well, the other thing is that integration tests are so expensive. Mm-hmm. Like, you're doing a lot. It's like testing a rocket by shooting it off. Like, that's great if it works. If it doesn't work, you, again, have a giant fireball, and you're like, well, something went wrong.
And integration testing is important.
Yeah.
You do need to test that everything works together.
Honestly, an integration test, I look at it as being a test that your unit tests worked.
Well, the thing is,
That they were sufficient.
the integration test should be testing that the different units of code work together.
Right. And, part of the way of doing that is going, okay, I know that I've correctly modeled this in my unit tests. That's kind of what the integration test does for you.
Yeah.
In a lot of respects.
Now, another thing is you'll need to create a single test for each possible place that an app could fail. Infrastructure tests verify connections to services like, say, an email server or databases, like we talked about earlier. They ensure that the cause of system failures can be pinpointed. This happens without going through the code that is actually working.
Right. So you may need to be able to spoof, errors, weird timing issues. I mean, there's a lot of stuff that can happen, especially at scale that, like, okay, it happens one time in a billion. Well, if you're running 10 billion transactions a day, it happened 10 times today.
Right.
And you don't really want to try to find that needle in a haystack with 10 billion pieces of hay in it.
Yeah. Unit tests are used to verify that your code connecting to the service is working. They're testing that the code that you wrote that calls the service makes a call.
Right.
Not that the service works or that what you're passing is what the service is expecting and vice versa. All it's testing is, hey, we're supposed to be calling this service
with these parameters.
Yeah. They also ensure that classes and methods containing business logic are functioning properly.
Integration tests may become redundant when unit tests are implemented correctly. In at least some of the cases that happens. You're already testing all the components that lead up to it. Now, I think this would be more simple, pretty simple cases without I/O.
Right.
So if it's inside the app and it's how two different classes talk to each other and you're doing an integration test of those, but you've done unit tests on all the things, you could probably toss that. Integration testing only tests how the components or units interact with each other, not their internal workings.
So next, we should only test behavior, not implementation.
Ask your manager if, to their mind, this seems like a reasonable way to test employee productivity.
Tests should assert behavior independent of implementation. Even if the internals of a method change, but not the output, the test shouldn't have to change.
Right. Looking at unit tests with lots of mocks, the code is similar to the code in the method itself. And this could be easily confused as a test that is asserting implementation as opposed to behavior. If you use a model of mocking dependencies, the test will follow this pattern. So it's going to look kind of the same, but it's not.
Yeah, your test is going to look very much like your code because of all the mocked dependencies.
Right.
And if you're properly using dependency injection, this becomes less of a problem.
Yeah. Although I do really, really hate spinning up lots of mocks.
Yeah. Well, the thing is, what I've done to avoid some of this is I've been using base classes and base repositories.
Yeah.
And trying to, as much as possible, only use the methods in the base. And that way I only have to create a few mocks.
Yeah. That's what you end up doing. Mm-hmm. Now, there may be times when changing the internals, but not the output, affects the tests. This can be due to assertions of the test being a little too strong. Like, for instance, I ran into an issue that I wish had been caught with a unit test, but wasn't, interacting with the Mandrill API. They call back on a webhook and they push stuff at us, right? Mm-hmm. And it's a HTTP form post. We get it, we do our thing, and we go on with life. Well, it turns out that the fine folks at Mandrill decided that this text field needed to include HTML for reasons, in air quotes. Well, it turns out, in addition to that ASP.NET Web Forms really doesn't like you posting HTML at it without telling it, because it's like, hey, this could be a cross-site scripting thing. And being that it's sort of a nanny framework, it says, I'm not going to let this through. I'm going to make it blow up. So you can end up with those kind of situations where it's like, hey, I don't feel like the input and output changed, but it really did.
Yeah.
So that will happen.
Also, making more calls than the ones using the mocking system, it's like mock in .NET, could cause assertion failures.
Right. Because you're saying, hey, this thing was only called once, but they go, well, no, it was called twice.
Mm-hmm. Now, I've run into that where I didn't realize it was making multiple calls, or the issue I had with the developer that came in and didn't use the DI that I'd put into the service.
Oh, so it wasn't calling it at all?
No.
Yeah.
These failures wouldn't be caught in integration testing. No.
And tests with mock dependencies may appear to be testing implementation, but they're actually testing behavior. They're seeing how the pieces interact. unit tests can catch duplicate calls, and they'll also find places where the dependency injection is not properly implemented.
Just like my situation.
Yeah.
Now, the next one that you'll hear is automated unit tests will not replace QA testing.
Did we assert that that was the case? No.
QA is necessary for testing user experience and integration. Less experienced developers are more likely to not test their code if they know it's going to be going through QA.
Yeah.
They'll just assume that, hey, bugs will be found by QA, so I don't need to test it.
That's why you need a QA guy that's a real jerk at least some point in your career that like finds, that pulls like floppy disks out while stuff is running off of it. Now granted, I just dated myself big time with that one. But once you've had that experience, you go, yeah, I'm going to test it more because it's going through QA because I don't want to talk to that guy. So that's kind of weird. The idea that that's not going to replace QA testing really bugs me because it's like, that's not the point of it at all. Evidence suggests that QA tests do not measure the integrity of the software. They measure whether it breaks in a way that you detect.
And it's interesting because QA, most of what they find is UI. Mm-hmm. Because they're more testing, hey, what is the user going to experience?
Yeah, it's user acceptance testing before the user acceptance testing.
Right. It really is. And sometimes they find bugs. Sometimes they say, it's always interesting talking to QA because they have a perception of the application like, oh, this is happening. I'm like, well, what were you doing? Most recently, I've been working on some search functionality and returning some CSV files. So it's like, all right, well, what did you search by? What did you do? This or that? And I'm like, all right, it's nowhere near what you think is going on. Yes, it's a bug. Yes, I need to fix it, but it's in a completely different area. And I get they're trying to be helpful, and sometimes it's really helpful. What's really funny is I've started to learn some of the things that the QA I work with likes, and so I'll go ahead and put those in, even if they're not explicitly stated in the acceptance criteria. We're sort of like,
it greases the skids though.
Yeah, it really does. Where it's one of those things. It's like, all right, this wasn't explicitly stated. I could do it this other way and it would be acceptable, but I know for a fact that the QA likes it this other way. So if I just do it the other way, I don't have to argue.
And the thing about it is, with a unit test, you can't argue. It's either right or it isn't.
Exactly.
And so that gets the human ambiguity out of the situation early on, and then you can add that back in when it's appropriate.
What we're really getting at here is unit tests and QA are two different things. Both are needed.
Yeah, it's like a programmer and a compiler.
Yeah.
We're going to replace all the programmers with a compiler. That'll work. No.
Right. The other thing is this doesn't include UAT. In most cases, UAT is an essential piece of the development lifecycle.
Yeah, there's some large software companies that I could argue maybe not so much. Don't worry, your machine is running on it. Yeah, it can be tested by internal staff or by external customers. UAT testing is for usability, and that includes some level of integration testing. But the other thing is they're going, hey, this doesn't make sense. Like, I don't have all the data I need to make this decision you're asking me for.
Well, I really, really liked what you said, and I'm going to use that from now on, which is QA is user acceptance testing before it gets to the user.
Yeah.
That's a really great way to think about it. Like, I'm going to tell my QA that tomorrow at our stand-up, because I'm like, hey, you got to hear this, because she'll really love it.
That's good. That'll be the one QA person on the planet that likes me. That's nice. That's a good thought.
So the final objection that we're going to talk about is improperly written tests can lead to a false feeling of security.
That's cool. Playing football without a helmet, great plan.
Tests can be written to pass without catching any issues.
That's absolutely true. I've seen some.
You can assert that true equals true.
Yep. Or you can only test the happy path and don't look for unexpected errors.
Mm-hmm. Now, this is something I have seen stepping into code bases a lot. Not so much where I work now, but some of the consulting I've done, I've looked into where it was side projects for people.
There's a reason dudes like us end up on consulting projects, and it's because that kind of code is there.
Yeah, that's very, very true.
That's sort of like, calling pest control. It's like you expect to see some roaches.
Mm-hmm.
Yeah. a lot of times developers are not looking for ways to break their code.
Yeah.
But you can find that behavior if you look at the unit test and you go, hey, there should be like 300 or 400 tests around this, and there's 20. Probably not testing all the things. Now you've got a metric you can use to actually find the bad code in a way that's maybe not as subjective.
Yeah. For example, what I talked about earlier with that expression tree that I was creating, I didn't even think about it caching the expression tree.
Yeah.
At all.
Especially like that.
Or think about like multiple calls within the same session to the same method. These were things that I didn't think about. I was testing a unit, and it wasn't until it got into dev and I was like, all right, let me make sure that all the things are coming back. I was actually testing that the UI and the API had the same view model, and the database view was populating when I ran across this issue. And then I went and wrote unit tests. I wrote like 4 or 5 unit tests.
As soon as you find a problem, that's what you do.
Yeah. I went and wrote those unit tests, and thanks to Hibernate for having the ability to look at the SQL that it creates, that's how I figured out what was going on.
Yeah. I mean, you can look at, an entity framework, like you can look at the SQL it creates. However, what you need is a really shiny shield so that you can, never mind. Otherwise you turn to stone. I'm just kidding. It's not that bad. It just makes you sick at your stomach.
Another thing you'll see is that developers comment out old tests when adding new functionality.
Yeah, and we've got a bit of that in our code base. And this means that they won't know if or how the new code breaks past functionality. So they're just trying to cram something in and get it done. And the unit test is going, hey, wait, I'm busted. And they go, you're commented out.
Mm-hmm. What it means is they're not testing if the new code breaks the past functionality.
Yeah, and I think there's a meta problem here in that you're also not testing that your tests are testing.
Yeah, that's very true. Because your tests, as we stated before, are living objects. They need to be changed with the code. It's also just a lazy way of coding that avoids updating the tests.
Well, and it's also really slow because, they're going to manually test stuff, right?
Yeah.
Like, that's the biggest thing I found with unit testing, just as an aside, is the amount of time it saves me on actually running stuff. Mm-hmm. Instead of, I got to run it, I got to log in, I got to go here, and I got to click this, I got to put this thing in this field, I got to hit this other button, I got to go over here, and I got to stop at a breakpoint, look at this, and it's like, or I could just right click and go run test, and I'm done.
Control RT.
Yeah, or Control RU.
Yeah, runs all the tests.
Yeah.
See what I was thinking
from orbit perspective, because there's no telling what I broke.
That's a good point. Well, I was just thinking when I'm testing a specific thing, I don't want to run. I just don't want to take the time to run all the tests when I know
we don't have enough yet where it's a problem.
Yeah.
And we've got fast enough machines, but it's like, I just kind of assume that I probably broke something and I need to carpet bomb it to see where it is.
Yeah, that makes perfect sense. Yeah, what we're really getting at here, guys, is that code changes need to be taken into account when you're writing your tests, and you need to update your testing and your tests when you update your code. So unit tests are code and should be treated as code when you're refactoring or doing anything in your code base. When you make changes to existing code that has test coverage, the tests need to be updated as well. This makes developers and managers in companies with tight deadlines less likely to build proper unit tests, and can lead to unexpected errors coming up in production, especially if the code doesn't go through any type of QA or UAT. Testing should be a part of your development lifecycle. You may face these common objections to unit testing, and use the information that we have provided to help you when you're having these discussions with other developers or management. That pretty much wraps us up before we close everything out. Will, what do you have for us this week for Tricks of the Trade?
I also want to add that you should be meta testing things. So when you're doing any kind of process, there should be a process that controls that process. You don't have to have a controller for the controller. It's just, if you're doing something and you don't have a way of asserting that it's working, how do you really know that you're doing it? And unit testing is a prime example of this. Like, if you're unit testing, that's great, but what you should also be doing is doing something like test coverage. See that all the execution paths in your code are actually being covered by tests so that you don't get surprised in production. If you have situations with your code review process, that's great. Okay, you're doing code reviews. Are you proving that you have reviewed all the code. If not, that code review process is weak and it's going to let something bad through. So always think about stepping up one more level and looking at the metagame. Not only will that keep things working that should be working, but it also is a way to kind of move forward in your career, because that's essentially what you do as you move up the corporate hierarchy, is you start looking at systems to keep systems running. And I just want to throw that out there as something to consider anytime that you're suggesting something like unit testing. That's a start. It's not enough by itself. So that's all I got.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up for weekly emails with extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Catch us each week as we broadcast live, talking about what's going on in the tech world and answering listener questions.
Learn more about all of our shows and groups by going to CompleteDeveloperNetwork.com, where you'll find links to Junior Developer Toolbox, Developer Launchpad, and our other communities. Thanks for listening. See you next time.